When we discussed balancing chemical equations, we discussed how these coefficients, the large numbers in front of the elements and compounds, represent how many of each type of compound or element react with each other. So this reaction that I have below says that 2 molecules of hydrogen react with 1 molecule of oxygen to make 2 molecules of water. But these numbers actually can mean something else. These numbers can represent moles. So we can rewrite what this says as 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. So these numbers can represent moles instead of just counting how many molecules we have. And this is really useful because from this we can create a mole ratio or a molar ratio. And all this is, if I wanted to represent the ratio between hydrogen and oxygen, I would say that this ratio is 2 to 1. You need 2 moles of hydrogen in order to react with 1 mole of oxygen. The ratio of water to hydrogen would be 2 to 2. And this you could simplify actually to 1 to 1. So a molar ratio just represents how many moles of one thing react with how many moles of another, or in this case, 2 moles of water can be produced from 2 moles of hydrogen. These molar ratios are very helpful. So I'm going to rewrite these in a slightly different way. So I will have 2 moles of hydrogen over 1 mole of oxygen. And I can do that for the other one as well. 2 moles of water compared to 2 moles of hydrogen. Well, why are we talking about these molar ratios? Well, these are going to help us in a little bit when we do stoichiometry. And remember, these fractions should remind you of something. They should remind you of that dimensional analysis that we did before. So let's see how we can use mole ratios to solve problems in chemistry.